folks, this is Stan Forster, your instructor. I thought I'd give you a little introduction to the Hertzsprung-Russell diagram. Let's... Whoa, that kind of went out of phase there for a little bit. Okay, so the temperature curve, what we call the spectral classes, okay? O, B, A, F, G, K, M. You can remember those. O, be a fine girl, kiss me. Or be a fine guy, kiss me. Let's be gender neutral there. Yeah, so we have those spectral classes, and that came about because when they were looking at stars and they didn't understand what all these lines meant, what all these missing dark lines meant in the spectra of these various stars, that they just began to group like ones together, and it came about that they figured out from chemistry that the simpler these lines were, it meant the hotter the star was, and the less complex the molecules could be in its upper atmosphere absorbing things. As you can imagine, a very cool star, which is still incredibly hot, 4,000 Kelvin, okay, is going to have more complex molecules, even some metals that are going to be there that at 30,000 Kelvin are just going to be completely blown apart, and you're just going to get hydrogen and helium there. Okay, so we have these spectral classes, and that worked for a long time. But then, we started taking more data, and it turned out we needed classifications that were in between, say, A0 and F0. So they decided to divide everything up between A and F into increments of 10. So there's A0, that's the hottest, A1, A2, A3, A4, so on and so forth. If you take a look here, our sun is right here. And if we drop a line straight down, we know that G0 is here and that G9 would be somewhere over here. So it turns out that our star is a G2 dwarf. It's a main sequence star. And that's one of the other things that we can look at, is that if there's a Roman numeral 5, G2V, it means that it's a G2 dwarf star. It's a main sequence G2 dwarf star. But there's other things here, like we have a supergiant, which there's the Roman numeral 1, 2, and 3. And these are populations. These are populations. They began figuring out, hey, wait a minute, it's just because something's a G2, that temperature has that spectral classification. This one is very different than this one, and is very different from this one. And oh my goodness, there's like a little tiny white dwarf down here. Okay, these are all very different. And so they began to give these different populations Roman numerals. And so the supergiants are Roman numeral 1. The giants, it turned out, the giants are kind of, maybe we shouldn't have given them two separate population names. Okay, so the Roman numeral 1, Roman numeral 3. The subgiants are here. You can see, so we have the 5. Here's the subgiants here. They're not quite giants yet. Okay, and those are probably evolving on their way up here, or they've done something strange where instead of burning hydrogen, they're burning helium right here. All right, these down here, these are the dead cores of giant stars. So you can imagine that we have like a really hot star up here, and it's burning things so quickly. It's burning hot. It's giving off enormous amounts of energy. It doesn't matter how much fuel it's got. It's burning it very, very quickly. It's going to live a very short time. Okay, and eventually what's going to happen is that it's going to start to sputter like a candle beginning to burn out, and its atmosphere is going to oscillate, and it's going to start throwing off gas clouds that we call a nebula, and that nebula is going to expand rapidly, and it's going to cool. And wait a minute, this is temperature, and that gas cloud's going to go shooting right off this scale, this direction. It's going to be way down here. We're not even going to see it. Okay, but the core of that star, the burning core of that star, that's the size of our planet, that is still going to be around there. But because it's got so much less surface area, it can still be the same temperature, but it's got so much less surface area, its brightness goes way down here. Okay, so we have temperature here, and we have brightness here. I didn't tell you about that axis, okay? So the brightness goes way down because it's like, you ever see somebody welding? If you were to get a dollop of molten metal on your shoe, that would be bad. That would be very bad. But they're in there welding away, and there's these little sparks of metal that kind of shoot off, and yeah, it might sting a little bit, but you're not in any serious danger. You can, if you weld for a whole a career, you're going to end up with all these little burn scars on your hands and your arms. But hey, whatever. People do it. Okay, and the reason is that just because it's just as hot, there's no surface area. It doesn't give off as much energy, even though it's just as hot. That little tiny surface area, and that's what a white dwarf is. A white dwarf is it's still incredibly hot, but it has so little surface area. It has trouble giving off that energy, but it does eventually. And these eventually they cool down. They become less bright as they lose temperature. They give off less energy, and they kind of migrate this direction. And we would call these black dwarfs over here, somewhere where we stop seeing them at all. Okay, so the main sequence stars are here, like our own star. These are the stars that burn hydrogen in their cores. Okay, and as you can, just to review, we have our spectral sequence, OB, A, fine, guy or gal, kiss me, and then there are the temperature gradations between them, B0, B1, B2, B3, B9, all the way to A0, and again. Okay, and then we have the populations. We have the supergiants, the giants, the subgiants, the main sequence, Roman numeral 5, and then we have the white dwarf, and I can't even read that. What is that? Okay, and there's one more that's not on there. It's the hypergiants. Okay, we're not going to really worry too much about that. All right, so I hope that helped. If you have any questions, please post them in the discussion board, and we'll see what we can do with that, okay? Let me upload this, and you guys tell me how useful this was or wasn't.